Hello, this is question 3 on your November 2021 paper 1 from OCR, the AHIS paper. And the diagram shows this curve here, which is a cubic, yeah? And you have to state the values of x for which fx, which is really y, is smaller than 1/2, giving your answer in Z notation. So this is 1, this is 1/2. So we are looking for the values that are values of x that are below this line, really, the 1/2 line. Yeah. Oh, this is not the 1/2. Where the function is below 1/2, here and here. So in this bit and in this bit, which is, I can tell, x1 and smaller, so before 1 and between 2 and 3. Yeah, so this value is 2 and this value is 3. Yeah, so it's going to be when x is smaller than 1 or when x is between 2 and 3. We have to write this in Z notation. Remember Z notation, what I'm going to do is to write the same, but x column and the brackets. So we have two sets here. We have x column x smaller than 1 and x again. So x column 2 smaller than x smaller than 3. And then to show that this or, I'm going to write the union symbol. Yeah, remember union is values from here or values from here. So that's the first part. Then on the diagram, in the print answer booklet, draw the graph of f of minus x. I'm going to do it here. And I'm going to remind you, when I have minus fx, so if I had minus fx, that's not the case, I'm just going to remind you. If I have this one, what I'm doing is multiplying all my y's, all my function by minus 1. So all the positive values become negative and all the negative become positive. So I'm reflecting in the x-axis. This transformation is more difficult to understand. So that's why I think it's better to remember this one. That makes more sense because I'm multiplying every y by minus, so all the positives become negative and the negatives become positive. And in this one, I'm mirroring in the other axis. So if this is mirroring in the x-axis, this one, when I multiply the x, I'm mirroring in the y-axis. Yeah, so that's what I'm going to draw. I'm going to mirror in the y-axis, and you should do it as well as best as you can. It's not easy, so you have to count a few points where you are passing by. Yeah, just checking more or less some points that you have to pass by. So the function is going to do something like this, down here, up here. I'm trying my best, but I know it's not easy. So they are going to give you the marks for the shape and more or less for passing the points. Yeah, the mark scheme says plus minus 2 millimeters, which means things like this one that maybe is a bit off will be fine. Yeah. So this is part B. And then explain how you can tell that fx can be expressed as the product of 3 real linear factors. This means that a cubic should be or could be expressed as a product of 3 linear factors. These are linear factors. Yeah, it's when I have only x and not x squared or x cubed. So if I have 3 real roots for my cubic, I will be able to express my cubic this way. But you can see that the cubic only cuts once the x-axis. Yeah, which means I only have one of these factors. The other is going to be a quadratic, and it's going to be a quadratic that has no real solutions because I don't have any more points of intersection. Yeah, to have 3 points of intersection, this bit should be lower, and then I could have 1, 2, and 3. Yeah, so if this goes lower, I will have 3 points of intersection, but I have only 1. Which means I only have one linear factor and a quadratic that has no real solutions. Yeah. How do you explain that? It's just one mark, so don't overthink. It's just fx cuts only once, you can say, or intersects, cuts only once the x-axis, Therefore, there is only one real root, and that means that there is only one linear factor. Yeah? And that's all with this question.